Good day everyone. Here we're gonna show you our thesis presentation entitled Automated Interface Liquid Vending Machine with Change Dispenser. Introduction. Water vending machine may be seen as a simple machine, but it definitely brings a lot of advantages, including low design time and production cost, conserves space, cost effective, minimizes power consumption, more compact, more efficient, more reliable, and is applicable for both indoor and outdoor environment. Moreover, it encourages a pollution-free community since it reduces the usage and disposal of plastic bottles. It also saves water because only the user desired quantity is dispensed. This machine is easy to use and can be readily accessed by an individual. This is very much helpful, especially in the remote sensing areas and those places where water is scarce. Thus, it helps in reducing the spread of diseases because of contaminated or unhygienic water by people. Truly, the automated interface liquid vending machine with change dispenser is a pathway towards welcoming the future technology that unleashes advantages to humanity and contributes much convenience to proper working habit of individuals as well as entering the eco-friendly world. Statement of the problem. Water vending machine is already commonly used in this era for business. On the basis of our survey, this system is coin operated, but most of it can only be operated using 1 peso coin, and the number one problem for each user is when they don't have 1 peso coin. It is a hassle for every user finding a coin that can operate the water vending machine. The researchers thought about using this system for a better and convenient way for the customers. Users and some of the businessmen can benefit in this particular way. The objectives of our study is to design and construct a low-cost automated interface liquid vending machine with change dispenser. To test the accuracy of the liquid vending machine using Raspberry Pi as its microprocessor. To test the accuracy of the device that the user is aware of how much the device can dispense a liquid and a change, but can only use a coin as a payment and a 1 peso coin as its change. The scope of the study is enumerated as follows. The device used Raspberry Pi as its processor. The device used a universal coin slot acceptor. The device can use any kind of drinking liquid. The device can produce 1 cup of water for 1 peso. The limitation of the study is enumerated as follows. The device can only accept old peso coins, specifically 1 peso, 5 peso, and 10 peso. The device can only dispense 1 peso coin as its change. The device will only use water for test in making the experiment. Significance of the study. This study will administer to provide a means of fetching liquid from the machine that requires lesser human effort. The researchers will obtain relevant information that could be very beneficial and useful in creating a better insight about the topic. Methodology of the study. First, designing of the device. The automated interface liquid vending machine with change dispenser is based on Raspberry Pi using Python language. The processes involved are based on the principle of vending machine. Using the touchscreen monitor as the controller that interacts with the user play an important role in the transfer of data. The data input sends an electrical signal en route to the Raspberry Pi board, which processes these signals. The following then sends digital pulses to the water pump after the user inserts a coin and then dispenses a change when the amount of coin is greater than the amount of the user need. Here we have our design of the automated interface liquid vending machine with change dispenser. Next, we have our block diagram of automated interface liquid vending machine with change dispenser. This shows the first three blocks. The transformer, rectifier, and regulator are used for getting a regulated power supply. The four blocks displaying water pump, coin sensor are interfaced. The dispenser will dispense water only when 1, 5, and 10 peso coin is inserted, as well as when the user selects the exact amount on the touchscreen monitor. The correctness of the coin is detected with a coin sensor. If both conditions are met, a signal is given to the microcontroller and the water pump is activated and the water and the coin chains will dispense. Next, we have the schematic diagram of automated interface liquid binding machine with change dispenser. This diagram shows the modules in our system. So the modules mainly classified into two, the input and the outputs. The outputs are the relays and the display, while the inputs are the touchscreen signal, universal coin slot, and the coin change pull circuit. Initially, the flow of signal starts from the touchscreen monitor. The system waits for the user to input commands which is translated into signal. Next, the universal coin slot sends pulses to the Raspberry Pi. Then the Raspberry Pi analyzes the pulses which is turned into information which is coin inserted. Next, the relay actuating the solenoid valve. The Raspberry Pi gives signals to the relay corresponding to the data inputted by the user in the touchscreen monitor concerning the amount of liquid they desire. Then finally, the Raspberry Pi gives off signal to the relay actuating the coin changer. Simultaneously, the coin changer pull circuit gives pulses to the Raspberry Pi. The information from the pulses are then used as reference as the Raspberry Pi when to trigger the stoppage of coin changer rotating motion using the relay. Next, we have the flowchart of the automated interface liquid binding machine with change dispenser. First, the user will press the insert coin in the LCD. After inserting the coin in a universal coin slot, the user will select the desired amount. Then the Raspberry Pi checks if the requirements to access is already met. Then it sends the information to the solenoid valve to start the pump for the required amount of liquid. Finally, the water and the change is dispensed. And after that, it will be back to main menu selection in the LCD. Here we have the operational output of automated interface liquid binding machine with change dispenser. Here we show you the table to test the functionality of our components. In the first column, we have the types of coins using 1 peso coin, 5 peso coin, and 10 peso coin. And the next column, we're using 5 trials for each types of coins. By using first trial to fifth trial in 1 peso coin, we detected that the coin sensor, water pump, coin dispenser, touchscreen monitor, and Raspberry Pi is 100% detected and functioning. As well as in 5 peso coin, using first to fifth trials, we detected that the components is 100% and functioning. And lastly, in 10 peso coin is also 100% detected and functioning. Here we have the table 2, coin changer and the water level accuracy. In the first column, we have the types of coins using 1 peso coin, 5 peso coin, and 10 peso coin. In the second column, we have the desired amount of peso coin. And the third column is the water dispensed in milliliters. And the last column is the coin change. By using 1 peso coin, we will have 250 milliliters amount of water to be dispensed and 0 change. And by using 5 peso coin, here we have the chosen variants when the user selected the desired amount and the equivalent water to be dispensed and also a coin exchange. As well as in 10 peso coin, we have the 10 chosen variants and the equivalent water dispense, and also the equivalent coin change in every chosen variants. Summary, findings, conclusion, and recommendation. The study intended to design and construct an automated interface liquid vending machine with change dispenser that can interact with the user and to lessen the hassle of every user finding a 1 peso coin to use the machine. Observational trial method was used in conducting the research. Observation guides were used as a research instrument in collecting appropriate data from the device. The following are the results and findings discovered after gathering, analyzing, and interpreting the data. The coin slot is capable of detecting every coin at 100%, especially 5 peso coin and 10 peso coin. The amount of water and coin dispensed differs depending on the amount of user's choice. The performance of the touchscreen monitor is good in that the user can interact well with the device. The water pump is functional with a timer. It controls the exact amount of water that is dispensed from the machine. Conclusion. Based on the data gathered, the device is effective and hassle-free for the user, that it can interact well with the user using the touchscreen monitor. After analyzing the gathered data, the device is at 100% detecting the 5 peso coin and 10 peso coin by the coin slot. All in all, the device is efficient and functional. Recommendation. The design of the automated interface liquid vending machine with change dispenser can be modified in the future. The modifications possible are the following. It is recommended to have an additional features like QR code as for the machine. Future researchers may use paper bell acceptor for the device. Future researchers may include security features in the device. This brings us to the end of our presentation. Thank you all.